started alkenes.
Sorry, can you say it again?
We started alkenes.
Alkenes, okay. Mm, all right, so alkenes. Reaction of unsymmetrical alkene. Have we done for symmetrical alkene? Um,
No.
no, we have done only for, yeah, we have done for symmetrical alkene. We haven't done for unsymmetrical alkene yet.
Yeah.
All right, fine. Just give me a minute, Zainab. Let me bring the book, right? All right. We are going to do for unsymmetrical alkene. Yours is AQA board, yeah?
Yeah.
All right. So just a minute, Victor. AQA. All right. Alkene is on page number, okay, 216. Alhamdulillah. Alhamdulillah. All right. Okay. We are done with this. So we need to start. Just a minute. Let me see. Hydrogen overall reaction with hydrogen halide is done. All right. Isomerism. So we need to do. We have done the isomerism. We need to start how alkenes reaction of alkene electrophilic addition reaction. Overall reaction, okay, fine. With halogenation, we are done with halogenation. We are doing with hydrogen halide. Yes, all right. Now we need to do it for the unsymmetrical alkene, or in your book it is written asymmetrical alkene, one and the same thing, right? So you can call it asymmetrical alkene as well. Alkene. Any question from the previous lecture, Zena?
No.
All right, good. Okay, now for unsymmetrical alkene, I'll give you the example for, let's suppose, butene. All right. Now, if we, or propene, start with the simplest one. This is propene, right? I hope we have done so much about nomenclature that you have the idea how to make the propene directly, right? Three carbon atoms, so it's propene, and there must be a double bond now. This is propene, but if you look closely at this compound, you will come to know that this is an unsymmetrical alkene. The reason being that the double bond, this is the double bond, and around the double bond, we have one carbon atom to this side and two carbon atoms to this side. Secondly, towards the right side, we have two hydrogens, and towards the left side, we have one hydrogen here and three hydrogen here. Here. So this is the example of unsymmetrical alkene. Symmetrical alkene is like this, CH2 double bond CH2, which is a very classic example, that is ethene. If you check ethene, this is the double bond, and around the double bond, we have two carbons on either side with two hydrogens as well. So in terms of carbon and in terms of hydrogen, everything is equal. So that is why it is called as symmetrical alkene, right? And as I told you earlier, the unsymmetrical alkene means the number of carbon and the number of hydrogens, they are not equal. Now, if there is a unsymmetrical alkene, then we do not do the reaction the way we have done here. Now here, if you remember, I told you that you can add hydrogen on either side, right? You can add hydrogen here or here. So it's entirely up to you that whether you want to add hydrogen here or bromidine here or here. But when you have an unsymmetrical alkene, then you have to follow a rule which is called as Markovnikov principle, right? So what is that rule? Let me first write it. Markovnikov rule. What is that rule? This rule states that if you are going to add, this is, keep this thing in mind, beta, this is unsymmetrical and this is also unsymmetrical. So when an unsymmetrical molecule is added to an unsymmetrical alkene, you know that this is partial positive and this is partial negative. So this rule says that the electronegative part of the molecule adds to that carbon atom which has the lowest number of hydrogen atoms. Is it clear? I'm repeating again. This is the rule, you need to memorize it, that the negative part of the molecule adds to that carbon of the double bond which is connected to the lowest number of hydrogen. So there are two carbon atoms, this one and this one. This is connected to two hydrogen. This is connected to one hydrogen. So this is the lowest number. So this bromide ion is going to go to this side. This is called as Markovnikov principle. Now, this is one thing. Now, why we are doing this? What's the reason behind it? So let me tell you about that reason. That, for example, first of all, let me make the product. So the product would be, what would be the product, Zena? CH3, yes, CH, and I'm going to write what with it?
Bromine.
Bromine, yeah, and single bond, and then comes CH, and the hydrogen will be added here, and it would be CH3. So this would be the compound. And what would be the name of this compound? 2-bromopropane. Now, this is the major compound we are going to get. And if we go against the rule, then what is going against the rule? That you are going to add bromidine to this side and H to this side. So you are going to get CO. You are going to get CH3, CH2, and CH2Br. So this is called as 1-bromopropane. This is called as 1-bromopropane. And let me tell you, this is the minor product. Now, why this is the major product and why do we get this? You can simply say this is because we need to follow the Markovnikov principle. But there is an other thing which we need to keep in mind. First of all, as the mechanism is in your syllabus, so I'm going to do it with the help of the mechanism, because when I will do it with the mechanism, you will come to know that why this has been formed. Now, if I will write it like this, that is if I write CH3, single bond C, double bond CH2, this is what? This is alkene. This is propene, the same thing here. All right, propene. Now, if I write it vertically down and I will take HBr with it, now what is going to happen? It is going to get a partial negative charge, giving a partial positive charge to the hydrogen atom. Eventually, this bond would get broken. And in the meanwhile, this double bond is going to give its extra electrons, which are the pi electrons, to this electrophilic hydrogen. All right. So what we are going to get, beta, we are going to get copying the same thing down, C H, and then comes CH3, because this hydrogen has been added here, CH3, and this carbon would get a positive charge. Now this is called plus Br negative. This is called as a carbocation. Now have a look that the carbocation you have formed in this way, it is a, which type of carbocation, can you tell me, Zena? Which type?
Is it secondary?
Well done. It's a secondary carbocation. Have a look. It is bonded to two R groups, so that is why it is called a secondary carbocation. And I hope that you know that secondary carbocation is what is stronger. It has greater strength as primary carbocation. Why? Because of the inductive effect. It is given in your book, so that's why I'm mentioning it like this. It is giving positive inductive effect like this. You need to mention it like this. In your book, they have exactly made it like this. So this is due to the positive inductive effect. First of all, you will write a secondary carbocation is formed, and secondary carbocation means that there would be what? There would be a positive inductive effect, which is written like this, plus I effect from both the R groups. This is an R group, beta, and this is also an R group. So that is why the secondary carbocation is what? It is stable than the primary carbocation. So this electron releasing effect tends to stabilize the positive charge of this positive charge of the carbocation. The more alkyl group there are attached to the positively charged carbon atom, the more stable the carbocation is. So that is why secondary carbocation is definitely stable as compared to the primary carbocation. Now, what would be the second step, beta? CH3 positive. It is going to react with the leaving nucleophile, this bromide ion, and I am going to draw the arrow from the lone pair, and we are going to get the product CH3Br. So what is it? It's 2-bromopropane, right? 2-bromopropane, just like this, right? This thing, 2-bromopropane. And if we had done it the other way around, that let's suppose if we do not add this hydrogen here, if we do not add this hydrogen here, and if we add it here, then we are going to get primary carbocation. Why? Because the carbocation is bonded to two hydrogen atoms. So that would be primary carbocation. Now, if we are going to get primary carbocation, it would not be stable because there would be lesser number of R group. So that is why automatically primary carbocation is not formed. A secondary carbocation is formed because the molecule knows that making a secondary carbocation is beneficial for it because it is going to get a support from two sides. So that is why we are going to get the major product as 2-bromopropane. Now tell me, is it clear to you? If you want to ask anything, please feel free to ask. Any
Yeah.
question, beta?
No.
All right, fine. I think when we did this with the functional group, now I haven't written it here. When you react alkene with bromine gas or bromine liquid, then what is it? It is called as test for the presence of double bond. Double bond. You know that bromine is orangish yellow in color. So when you are going to add it into an alkene, what is going to happen? The reddish, orangish yellow or reddish brown, both the colors are correct. So when you are going to add few drops of bromine solution, and it is also called as bromine water, and when it is added to alkene, the solution is decolorized because the double bond would be present in the alkene, and that is why the reddish brown color would be decolorized. So this is the test for the presence of alkene. I'm going to highlight this. Okay, coming back to this thing. Now, the next reaction we are going to do is reaction with concentrated sulfuric acid, H2SO4. All right. So, concentrated sulfuric acid also adds across the double bond. The reaction occurs at room temperature and it is exothermic. Repeating, this reaction is number one, exothermic, and it takes place at room temperature. Why at room temperature, Zena? Because we are using concentrated sulfuric acid, right? So we are going to write like this, CH, this plus H2SO4, and we are going to get the product. I'm writing the whole reaction, and we are going to get the product H, H, C, H, and then the additional H would come here, and HSO4, which is mostly written like OSO3H. Basically, this is equal to HSO4, but we write it like this, right? Because the bond is formed with oxygen, like this oxygen, okay? Otherwise, if you will directly write HSO4, it would not be wrong, okay? But if you are going to write HSO4, which you know that hydrogen will make only one bond. So if I wrongly write it like this, CH, H, and if I write uh, HSO4, then this would be wrong because hydrogen makes only one bond, and here it is making two bonds. So that is why we do not represent it like this. We know that the valency of oxygen is 2. So you can see that oxygen is, I'll use a different color. Oxygen is making one bond here and the other bond here. So that is why technically it's correct. Does it make sense, Zena?
Yeah.
All right, fine. So what is the name of this thing, beta? The name is ethyl hydrogen sulfate. Okay, ethyl hydrogen sulfate. Now, the electrophile is a partially positive charge hydrogen atom in the sulfuric acid molecule. And you know what? If I'm going to break it, it would be HOSO3H. Now, this would be partial positive and this would be partial negative. So, what is the electrophile in it? Again, hydrogen, just like this thing, because until and unless this molecule shows some part of it as an electrophilic part, the double bond will not share its pi electron. So in order to show, if you want the alkene to share its pi electron, then you have to show one part of the molecule as electrophilic center. So here it is. So when we will do the reaction, it would be like this. Now it's a very important reaction. You have to memorize it like this. So H, and H. Now I will write this vertically down here. HOSO3H. Now this is partial positive. This is partial negative. So definitely the pi electron will be given to this hydrogen atom. In the meanwhile, this bond would be broken. And what we are going to get, Zena, we are going to get C. Okay, I'll use the same color. C, H, H, C, positive, H, and this H will be bonded here like this. Now it's a carbocation. You can see it's a carbocation and it's a primary carbocation. Why primary? Because this carbon is connected to two hydrogens and one R group. So it's a primary carbocation. You know that primary carbocation is not stable. So it is going to react with this leaving nucleophile. You know that this would be given out as this. All right. So this would be just like this one, just like this one. It's a leaving nucleophile. So when this carbocation is positively charged, it would react with the leaving nucleophile. I will write it like this, SOSH3H, negative. But I will never start the tail of the arrow from the negative charge. I am going to start it from the lone pair, and then it is going to attack on this, sorry, it is going to attack on this electrophilic carbocation. Sorry, not electrophilic, carbocation. It is going to attack the carbocation, and we are going to get CH, CH, and now with a different color, I am going to write sorry, O SO3H. This whole thingy is going to be attached here with the carbocation. And now this is the product we have got. So what has been formed? If when water is added to this product, now this is the product which we have got, right? This is the product we have got. Now, it is called as ethyl hydrogen sulfide. I have already written the name ethyl hydrogen sulfate here. So have a look because there are two carbon atoms. So this is ethyl and this is hydrogen sulfate. Now, this ethyl hydrogen sulfate, when it reacts with water, when water is added, so I'm going to write this again here. That is CHHH. You have to memorize it very carefully. SO3H plus HOH. Now, as I told you earlier, never write water like this, H2O. If you are going to write like this, HOH, it will be easier for you to make the compound. So, what is going to happen? Because they have not given the mechanism of this thing, so I am directly writing it. So taking the previous one like CHHH and this OH is going to come here, and this whole thing will combine with this thing to make sulfuric acid. So this shows that sulfuric acid is used as a catalyst because it is regenerated towards the end of the reaction. So I'm highlighting it. This OH is going to come here, this OH is going to come here. So if this OH is going to come here, that means this is removed. This is going to combine with this to make sulfuric acid. Now we have got ethanol plus H2SO4. And because, as I told you earlier, that H2SO4 has been regenerated, so that means sulfuric acid acts as a catalyst in this process. This is a very hot favorite question of the as examination point of view, because they mostly ask that how do you take it with concentrated sulfuric acid when added to alkene, what type of reaction is that, and what is the function of sulfuric acid. So you are going to write that this is actually a catalyst. That's it about the reactions of alkene. However, I have made an acronym. That acronym is reaction of alkene. So what you can write tetra H and P. Now, first H stands for hydrogenation. The second one stands for halogenation. The third one is hydration, or the fourth one is hydrohalogenation, and the fifth one is polymerization. So we are done with all these reactions. However, it is actually this hydrogenation and polymerization can be grouped together, because when alkene is added to when hydrogen gas is passed through alkene in the presence of catalyst, nickel catalyst, and a temperature of 150 to 250 degrees centigrade, we are going to get H, single bond H and H. So I'll write H2 as HH. So what is going to happen? One hydrogen will be added here across the double bond, and the second hydrogen will be added here. So what is happening? Ethene is being converted to ethane. All right. And this is basically polymerization. But in your syllabus, it is given as a different topic. So I'm going to deal it in a different chapter. So again, repeating, this is hydrogenation, halogenation, hydration, hydrohalogenation. What is the meaning of hydrohalogenation? This one, HX, this. This is basically hydrohalogenation, right? So repeating again, hydrogenation, halogenation, hydration, hydrohalogenation, and polymerization. So these are the 5 reactions in your syllabus. So if you are going to keep this in your mind that there are 5 reactions, and if you are going to remember this tetra HP, so it will help you a lot in knowing about the reaction. Does it make sense, Beta?
Yeah.
All right. Now we are on the next topic of your book, that is 14.3, that is addition polymers. Addition polymers. I am trying to finish off the syllabus quickly. I try to cover as much as possible. That is why I do not ask many questions from you, Zena, because I want to finish the syllabus first and then we will go through the past papers. Because until unless you prepare it from the past paper, or if you have a good practice of past paper, then you will be able to do the questions quickly and easily in the exam. All right. So that's why I'm doing it quickly. So once we are done with the syllabus, then I'm going to do past papers with you, right? However, it's entirely up to you, beta. If you want to do the past papers in between, you can tell me. But if we will be doing past paper, then definitely we will be covering less syllabus. Okay. So please decide about it, because I know that past papers, they go good, they give a very good practice. So think about it and then let me know. All right.
Okay.
Okay, addition polymers. Now, when we talk about addition polymers, you know what? We if you look around right now, wherever you are sitting, if you look around, you will come to know that we are surrounded by polymers. Everywhere polymers are present, whether it is in the form of rope, whether it is in the form of any plastic thing, whether it is in the form of toys, even the laptop which you use, the keyboard of the laptop is made up of polymer, right? So even the switchboard boards at home, when you switch on the button to turn on the fan or something, that board is made up of polymer, right? So polymer is all around us, right? And what are they? They are the large molecules that are built up from small molecules, which is called as monomer. So if I write the word polymer. Now, these are the two words. Poly means many and mer means parts. Anything having a lot of parts is called as polymer. And polymer is originated from monomer. Now, what is monomer? As you know, that mono means one and mer means part. One part. So, if you want to make a polymer, you have to take different monomers, then you join them together and you get the polymer. Now, when we talk about the polymers, broadly, polymers are divided into two main categories. That is, number one, polymer can be divided into two main categories. And what are they, beta? The first one is addition polymers, and the second one is condensation polymers. Now, condensation polymers. Now, addition polymer means that this polymer is formed by the addition reaction, right? And to keep this thing in mind that we are discussing alkenes. But right now, I'm simply telling you about the polymers. Polymers are of two types, addition polymers and condensation polymer. Condensation polymer is a word which has been taken from condensation polymer. Condensation means water. So a water molecule is eliminated when this polymer is formed. But it is not in your syllabus. In your syllabus, we have only addition polymers. So we are going to discuss only the addition polymer. As I told you earlier, in case of addition polymers, we are going to take the monomers. And as we are studying it under alkenes, so it means alkenes is involved in it. So have a look here, beta. Addition polymers. So I will take, let's suppose, three molecules or four molecules of alkene. Now have a look. One molecule of alkene plus an other molecule of alkene, right? Second molecule of alkene plus third molecule. Okay, I'll make three molecules only because we have less space. Now, what is this? This one unit is called as monomer. So how many monomers I am taking, beta? I am taking three monomers. One monomer, second monomer, and the third monomer. When I am going to join these monomers, beta, what is going to happen? I am going to rub this plus sign, Now, and how a polymer would be formed? This double bond would be used in connecting these two carbon atoms. These two carbon atoms would get connected by using this bond. So this bond, repeating again, bete, this bond opens up, it goes to this side, and there would be a bond formed between carbon and carbon. This bond opens up and it will go here and it will combine with the next carbon. So this process is repeated many times and we get a polymer. So when this happens, what we are going to get? One, two, three, four, five, six, and I am going to write like this. And H, I am going to put all eights around, and this line would be the last line from the terminal carbon atom would be longer like this. And then I'm going to make a bracket here. All right. This is called as a polymer. All right, beta. So, sorry, this is the simplest polymer. Now, what did I take? I took ethene, three monomers of ethene. And what I'm going to get? A polymer which is called as ethene, because the monomer was ethene, so it's in the name that the polymer is polyethene. Is it clear? However, if you count the numbers of carbon atom. So you will see that one, two, three, four, five, six carbon atoms in the monomer, and we are having six carbon atoms in the polymer as well. It means that the number of carbon atoms remains the same. The only thing which changes is now if but this also comes in the paper that sometimes they ask you to find the monomer from the given polymer. They will ask you to find the repeating unit. So repeating unit, repeating the word is repeating unit. So if they ask you to buy, sometimes it happens, they give you a polymer and they ask you to find out the repeating unit. So beta, have a look very closely. This is the repeating unit. So have a look. Three monomers, one, two, three. Three monomers have been joined together with these two bonds. And how these two bonds have been formed? By opening up this double bond. So this is the monomer. So when you look at the polymer, what you do is, in order to find out the monomer or the repeating unit, you look closely at the monomers which have been involved, like this, making a circle and then checking that what type of polymer has been made. Does it make sense, Peter?
Yeah.
All right. Now, let's suppose, Bete, if we have phenylethene, phenylethene. Now, phenyl means C6H5. Phenyl has a formula, this thing, right? If this is now you will say that, Miss, this is actually six carbon and six hydrogen. You are absolutely right. Have a look. One, two, three, four, five, six. And this ring is actually, let me clearly show you how this has been made, like this, right? And then for with each carbon atom we have a hydrogen atom, and this is called as phenyl. And if you check the valency of carbon is satisfied. How come? Let's check this carbon. Now this carbon is 1, 2, 3, and 4. So the valency is satisfied. So each carbon is joined with one hydrogen, and there are three double bonds in the ring. But I'm not going to make it tougher for you, so I'll keep it simple, that just simply memorize this, that this is a phenyl group. All right, so phenyl ethene. So first I'm going to draw the structure of ethene like this. And then beta, I am going to replace one hydrogen with the phenyl group. I am going to replace one hydrogen with the phenyl group. So here it is, like this. So this is phenylethene. Now again, beta, I am going to take three monomers of phenylethene. I'll copy this and I am going to paste image, paste image, and paste image. Now have a look, beta. You have three phenylethene monomers. You are going to join them by putting a plus in between, and then what is going to happen? Beta, this bond this double bond would open up here, this double bond would open up here. And what I'm going to get, Zena, I'm going to get this. Now you will, here you write it in, here you are going to write it in which form? In diagonal form type thing. But when you will make a polymer, then you will write it in straight form. Just a minute, Zena. Give me 10-15 seconds. I'll be back. Sorry for this interruption. All right. Sorry for the moderation. All right. So now I am going to get beta H now down. Then this line is actually, let me write it with a different color so you'll get the idea from where you join the monomers. So, oh dear, single bond, and then again beta this, then again a line, and then a single bond, and then this. Now, HH, HH, and HH, H, and then beta, this would be like this. All right, like this, and then H, then like this, oh dear, and H, and then again like this, and we are having H. Now, this is a polymer. But when you make a polymer, always don't ever forget to make these lines long and then making a bracket here. And now, what is the name of this compound? As I told you, this is phenylethene. So, what would be the name of this compound polymer, Zena? If the monomer is phenylethene, what would be the name of polymer?
Poly.
Polyphenylethene. Polyphenylethene. So what change did I make? Just I will add the word poly before this phenylethene thing. So it becomes polyphenylethene. Is it clear, bache?
Yeah.
Okay. So and you need to know about the monomers. In your book, I have told you about two monomers. That is, the first one was ethene, then we made polyethene, then we had phenylethene, then we made polyphenylethene, right? So even if you take propene, then if you take propene, then you can make polypropene, right? So how is it so? When you write propene beta, this would be like this: one, two, CH3, CH double bond CH2. So if I need to make, this is propene. Now, if I take three monomers of propene, it would become polypropene. Now, let me tell you a trick here. The trick is always concentrate on the double bond. Now, how I am going to do it? Have a look. Bete, I will write C double bond C. I am taking this thing. All right, C double bond C. Now, this is H2. So I am going to put H and H here. And this carbon, beta, this carbon, oh, sorry. This carbon is connected to now one hydrogen and one CH3 group. So I will write H and CH3. So you need to write polypropene like this. If you are going to keep it like this, you won't be able to make the polymer. It would be very hard for you to make the polymer. So what is the trick behind it? Beta, the trick is to block the double bond, to block the double bond. Is it clear? So in this way, you can easily write. Okay? Now, in this way, you can easily write it. Is it clear?
Yeah.
All right, fine. So you will write it like this. Then again, for you will take another. You will take an other monomer. This is Propene. Now, this is a very different way of writing propene because students, they are used to write propene like this, like this. Don't write it like this. Like as I told you earlier, block the double bond and then write. Now again, this H, CH3 and H. Again, now you have joined three monomers, beta, 1, 2, and 3. And now again, you will do the same thing that you will stretch this bond, open up this bond, and then you are going to connect them and you will get a polymer. And your polymer is going to have the same thing that is H two. Now have a look. One more thing. H like this, and then CH3H, CH3H, CH3H. So your polymer would follow the same sequence. That is H, and then CH3H, 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 like this. Now what would be, because the monomer was propene, so this polymer would be polypropene. Is it clear, beta?
Yeah.
All right. Now you will tell me how to arrange it. I am telling you CHCl double bond CH2. Now, how will you arrange it, Zena? By the
Will
way,
you,
this is, can you tell me the name first? What would be the name for this?
um, is it chloromethane?
Beta, there are two carbon. Chloro,
Chloroethane?
well done. So it is chloroethene. Chloroethene. So how you will arrange it, beta? And now, first of all, tell me if the monomer is chloroethene, what would be the name of the polymer?
Polychloroethane?
Yeah, polychloroethene. Now, tell me how to arrange it.
Will you,
Sorry,
will you write 2 carbons
write this. Yes, then.
and then 2 hydrogens
Okay. And then,
and then 1 hydrogen, 1 chlorine?
well done, well done. So you are going to, this is the way. Good. So you are going to copy. So you are going to take another one. You are going to take another one, right? So now what you are going to do, you will simply, beta, you will simply stretch it like the, open up the bond like this. And after opening it up, you are going to get, again, keep this thing in mind that follow this H, and then CL, oh dear, then CLH, right? So in this way, now you can simply make the polymer, and don't forget to, so 6 carbons. So the question comes in the paper that what's the difference between polymer, monomer and addition polymer? The number of carbon atoms, they, would not change. Keep this thing in your mind. That's a very important thing. Now you will simply do like this, and then H like this, and then CLH. One thing more, if you are taking 3 monomers and in your answer for making polymer, instead of making 6 carbons, sorry, 6 carbons, if you make 5 carbons like this, you forget to you forget to make the 6 carbon, then your answer would be wrong. So if there would be 1, 2, 3, 4, 5, 6 carbons, then you need to make 6 carbons. Is it clear?
Yeah.
now, now, I have already done that with you. That is identifying the monomer from a polymer. From a polymer. I have already told you, for example, this is given to you. What you need to do is you will just check the polymer, and then you will highlight the monomer. And this is the monomer. So you will identify the monomer like this. Is it clear? Okay. Now, the next one is modifying the plastics. Now, it's a very small topic. I'm simply going to do it quickly. The properties of the polymer material can be considerably modified by the use of additives such as plasticizers. What are plasticizers? These are the small molecules that get between the polymer chain, forcing them apart and allowing them to slide across each other. All right. So, for example, PVC, which is called as polyvinyl chloride, is very hard enough for use as drain pipes. All right. But if you are going to add plasticizer in it, it becomes flexible enough for making aprons. Now, it is very different thing that PVC can be used to make drain pipes. And you know that drain pipes are really very hard and inflexible. But if you take PVC again, but in PVC, if you add plasticizers, then what is going to happen? You can make aprons. And you know that it's like a cloth, simple cloth. You can fold an apron, right? You can just put them away by folding it. So you cannot fold a drain pipe, it will break. So look, the polymer remains the same, but only by adding plasticizer you can change the polymer. That means first it was hard and inflexible. Now it would be very soft and flexible. Is it clear? So this was about modifying the plastic. I'm trying to explain it in simple words and quickly so that we can cover more. Is it clear? Should I go to the next point, Zena?
Yeah.
All right. Any confusion, beta?
No.
All right, fine. So biodegradability. Now, biodegradability. What do you understand by this word, Zena?
Um.
What
Not.
I can help you by doing like this biodegradable. Now, anything comes to your mind?
Um. Like stuff that can be decomposed
Well done.
naturally.
Yes, degradability means something decomposes. Something decomposes, and bio is something like definitely like if you say naturally, but how can you biodegrade as polymer? Naturally means bio is actually is a word which is used for microorganisms or enzymes. So basically, you use microorganisms or enzymes in order to decompose the polymer. So this is called as biodegradability. All right. Nowadays, scientists they are trying to make a polymer which is biodegradable, because if the polymer is not biodegradable, it is becoming a very big problem in today's world, where waste disposal is becoming more and more difficult. Because you know what, if you are polythene bag, maybe you have seen the polythene bag, yeah. So if you are going to put polythene bag somewhere, it is not going to degrade after even 10 years. It is so strong. Although it is going to get holes in it, the shopper would get holes in it, but it is not going to decompose. So it creates a lot of problem, not for the environment, but for the marine life. So you must have seen some marine life being trapped with the polymers. Have you ever seen something like that? Yeah.
Yeah.
All right, fine. So now comes another one, that is high density and low density polyethylene. Now it is called as high density polyethylene and low density polyethylene. Now, high density polyethylene is made at temperature and pressure greater than the room condition, right? And Ziegler-Natta catalyst, that is the name of the catalyst which is used to make high density polyethylene. So, what does it mean? That HDPE stands for high density polyethylene. It is going to be made at a high temperature and high pressure, and by using a catalyst which is called as Ziegler-Natta catalyst, right? So we use these catalysts to make this high density polyethylene polymer. And the chains can be, why do we use it? Now, you know what? When we are going to make the polymer, even the branch of the high density polyethylene will have 200 carbons. Now, this is a lot. Actually, beta, this is polyethylene. Now, if this branch is going to have 200 carbon atoms, then it will become very dense, and then it is called as high density polyethylene. And the chains are packed together well, and this makes the density of the plastic greater, and then its melting point gets higher, right? So the milk crates, bottles, buckets, they are made up of high density polyethylene, because if you are going to make a bucket of low density polyethylene, when you are going to put a good amount of water in the bucket, it is going to break because of the weight of water. So you have to make it with high density polyethylene. Is it clear, beta?
Yeah.
Yes? All right, fine. Now comes the recycling. Recycling. Now we are going to do the recycling of the polymers. Now, in your syllabus, they have given few ways of recycling polymer. Why do we need to recycle polymers, Zena? What comes to your mind? Why do we need recycling of the polymer?
Um.
For example, let's suppose if I have a bucket at home, I use it to store water. After some time, that bucket got broken. All right. Now, if I put water in it, the water is going to drip down. It cannot hold the bucket cannot hold the water. The water will start spilling out of it. Now, it is useless for me. So I won't be able to use it more. So I am going to throw it away. So what do you think? So why do we need recycling? Do you think if I'm going to throw the bucket outside, do you think it is going to decompose naturally after 2, 3 months? Yes, Zena?
Yeah.
No, but no, it will not decompose naturally, because the most of the plastic which we use, they are not biodegradable. They are non-biodegradable plastic polymers. So if I'm going to throw that bucket away, that bucket, the broken bucket, would remain as such for a couple of years. Rather, for 4, 5 years, that bucket would remain the same. So if that bucket cannot be used, then what's the point of having it? It is going to create problems for us. It is going to make more debris. So we need to get rid of it. So what do? We need to recycle it. Now, what happens in recycling? That bucket is going to be melted, and after melting, we can put it in a new mold, and then we can make a new thing out of it. Are you getting my point?
Yeah.
This is called as recycling. All right. So the two forms of recycling. Recycling comes after the polymer is not of any use. Polymer is discarded. When the polymer is discarded for any bucket, let's suppose any rope, anything which is not in use now, and because its functionality has been stopped, that means it can't function anymore. So we have to recycle it. Now there are two ways of recycling: mechanical recycling and feedstock recycling. All right. Now, what is mechanical recycling? The actually, in case of mechanical recycling, it is the simplest form of recycling, and as indicated by the name mechanical. Mechanical means that you are going to separate the. Maybe you have got. Have you ever noticed that sometimes outside our houses there are three bins placed of different colors? All right. And we have been told that we need to put plastic thing in one and the glass things in other. Have you ever seen that? Yeah.
Yeah.
Yeah, so that is actually to make the recycling easier. So we separate the different types of plastics, and then what happens? Then they are washed. When they are taken to the industry, they are washed, and once they are sorted, they may be ground up into small pellets. That means that we ground them up. We grind the polymer, and we after grounding them up, then into small pellets, they can be melted. That means first they are broken down into small pieces. After that, they are melted. So I'm going to write. First of all, they are number one, they are broken down by machines. Broken down by machines into small pellets. Now, these small pellets are heated and they are melted, and then they are remolded to make new things. So that means the plastic can be reused again. This is called as recycling. So, you know what? Soft drink bottles, they are made up of polyethylene tetrafilate, and they are used to make fleece clothes. So the drink bottles can be used to make fleece clothes. So how can you make fleece clothes? By using PET, polyethylene tetrathylate, right? So we can the same process that first we break it down into small pellets, then we heat it, melt it, we remold it, and we can make new thing out of it. So this is called as mechanical recycling. Now the other name that is called as feedstock recycling. All right. Now, what is the meaning of feedstock recycling? Feedstock recycling means that you do what? You heat the plastic to a temperature that the polymer bonds are broken and monomers are used. So again, heating is used, but in case of feedstock, heating is used to make monomers from the plastic. And now these monomers can be used to make new polymer. So this is why the feedstock recycling is called as thermoplastic. For example, polypropylene, it is a thermoplastic. This means that it will soften when heated, so it can be melted and reused. However, you cannot remold the plastic more than two times. After two times, it becomes so hard that you cannot melt it easily. So that is why if you cannot melt it easily, then you have to you have to give it more temperature treatment. For this, you need more fuel. So if you want to remold plastic, you can do it two times. After that, it is useless, because otherwise, if you still want to remold it by heating it, then it is quite expensive, because we need to set up a proper plant to to melt the plastic. Is it clear?
Yeah.
All right, beta, we are, Alhamdulillah, we are done with the whole chapter of alkene. Now we need to start alcohol. By the way, Zaina, I was thinking of doing some past papers with you. Now, can you tell me, we are on 15th chapter. After alcohol, we need to do, it's quite a big chapter. Then we have organic analysis. That would be, I think, this would be the last topic. Then comes thermodynamics. Yeah, that is the last topic of organic chemistry. Then tell me, beta, what do you want to do? Because after that, we have only one chapter, alcohol, and then the synthetic root chapter. What to do? Because we haven't done the past papers. So what should we do?
Past papers.
Can we do past papers next time?
Yeah.
All right, fine. So better do revise these chapters. Which chapters have we done? Let me just open the index so I can tell you. We have done, yeah. When we started organic chemistry, first we did introduction to organic chemistry. After that, we have done alkanes, then halogenoalkanes, then alkenes. All right, and now we are only left with alcohols and organic analysis. After that, our organic chemistry would be complete. All right, so we are going to do some questions related to introduction of organic chemistry, alkanes, halogenoalkanes, and alkenes. Would it be fine?
Yeah.
All right. So I'll make a document and I am going to share it with you on Notability and then we will solve it together. All right. Okay. So
Okay.
better do practice from the past paper and do revise all these one, two, three, four chapters. All right. So we are going to do the past paper. Any question, beta?
No.
All right. Okay, fine. Okay. Inshallah, in the next class, we will do the past. Okay, Zainab.
Okay.
Thank you very much, Bete. Take care. Allah Hafiz.
Allah Hafiz.